Okay, so in this video, what we're going to do is we're going to learn about the basic idea of logarithms. Now that may sound scary to you, but trust me when I say logarithms are very, very simple if presented in a simple way, and that's what I intend to do, okay? Now, logarithms are basically the same thing as exponents. Let me show you what I mean by that. I've already shown you in a previous video that we could say 5 to the third power is equal to 125. And we have three parts to this this mathematical statement, okay? The 5 has a name. We call that the base. And so when I explain things, I'm going to use these words, and you have to know these words that I'm using. So the 5 in this case is the base. And even when we change its form, the 5 is still going to be called the base of the exponent, okay? The exponent is 3. So this 3, we already know that, or sometimes we call it the power, but its technical name is the exponent. Now, what's really funny is that there's another word for exponent, and the other word for exponent is logarithm. So we can actually call 3 the exponent, but we can also call that 3 the logarithm. We can call it the logarithm. So this is 5 with a logarithm of 3 is equal to 125. Now this 125 can go by a few names. I like to call it the product. The reason I like to call it the product is because it is the result of a multiplication, right? 5 times 5 times 5 equals 125. And therefore, it is a product. But in logarithms, it is often referred to as the argument. And we'll see where it finds itself in a logarithm, okay? And so we have already seen when we did rational exponents that we can rewrite this by putting the base by itself. We can say that the base is equal to the exponential root of the product 125. So if we were to do a radical symbol and put the exponent in the what's called the index of the radical, put the product underneath the radical, it would be equal to whatever the base is, okay? So in this question up here, the answer, the thing that's all by itself, is the product. But in this one, in the radical form, the thing that's all by itself is the base. Well, you may be asking yourself, is there a kind of question that gives the exponent as an answer all by itself? And the answer is yes, and it's called a logarithm, okay? And so typically with a logarithm, what we do is we just write the word log, log, that's short for logarithm, okay? And what we do is we take the base, this number right here, the 5, and we put it down really low, and we write it really little next to the g, right after the g. And the way we say this is log base 5. This is log base 5. Why do we say base 5? Because the base of the exponent is 5. But remember, an exponent is also a logarithm. So we can say that the base of the logarithm is 5. The base 5 here of the exponent 3 of the logarithm 3 is 5. So log base 5. And then what we usually do is we put in here, in parentheses, we put the product, this 125. But in a logarithm, we usually call it the argument. So the argument of the logarithm is 125. And so this is a logarithm, that log base 5 of 125 is equal to 3. Another way of saying this is, what exponent on 5 will give us 125? Or 5 to what power will give us an answer or a product of 125? And so what we'll see here is this. The way I often see it in my mind is I take the 5 and I say 5 to some power is equal to 125. And that's what a logarithm is. It is, I promise you, it is no more complicated than what I just explained. And so what we're going to do now is we're going to go through a few examples of some basic logarithms that are based on the idea that you already know that 2 squared is equal to 4. You already know that 4 to the third power equals 64. You already know that 9 squared is equal to 81, and you already know that any number like 17 to the 0 power is equal to 1, okay? And so what we'll do is we'll take these 4 examples right here, and we are going to turn them into logarithms. Okay, let's do this first one here. I'm going to do a double arrow here. This is the same thing as log. And then we have to put a base. Well, what is the base of this exponent? The base is 2. So log base 2. And then what do we put inside the parentheses? We put the product over here. So we're going to put that 4 in here. And what this is saying is 2 to what power equals 4? Well, the answer is 2. 2 to the second power equals 4. So 2 to the second power equals 4. And so log base 2 of 4 is equal to 2. Okay? Do you want to try this one on your own? Just pause the video. All right, now let me do it. Okay, so this, we know that 4 to the third power is equal to 64, and that means that log base, what's the base of the exponent, is 4. Log base 4 of the product, which is 64, equals, and this is saying 4 to some power equals 64. Well, we know that 4 to the third power equals 64, and therefore log base 4 of 64 is equal to 3. You may be thinking it can't possibly be that simple, Mr. Ryan. I'm telling you that's exactly how simple it is. You may be thinking, Mr. Ryan, I know I've done logarithms before, and it was very difficult. I agree that there are some more complicated elements of logarithms, and we're going to get into some of them. But for now, we need a foundation. I'm telling you that that is exactly what logarithms mean. It is as simple as that statement right there. It's just written in a different form. Why don't you try this one on your own? Okay, so now we're going to write the word log. We need the base of the exponent. The base over here, the base of the 2 is 9 of 81, because the product is 81, is equal to 2. 9 to the second power is equal to 81. This is saying what logarithm or what exponent on 9 equals 81? The answer is 2. All right, now this one is a very special one. Can you try this one on your own? All right, so we're going to write the word log. Now, when I say it's special, I'm not saying the 17 is special. This could actually be almost any number, okay? What I'm saying is that this power of 0 and this answer of 1 are special, okay? So we know that this is log base 17 of, the answer is 1, equals, and what this is saying is, what exponent on 17 will equal 1? Well, we know that the only way you can get 1 is either 1 to the first power, right? Or 1 to the 17th power. Don't worry about 1. But if the number down here is not 1, the only power that you can raise it to and get 1 as an answer is 0. 17 to the 0 power is 1. But we also know that anything except for 0, anything to the 0 power equals 1. So we can say that log base 97 of 1 is equal to 0. We can say that log base 1.73296 of 1 is equal to 0. Anything, any log to the 0 power equals 1, or sorry, any base to the 0 power equals 1, and that means any time that you see log base anything, I'll put an A down here, of 1, answer to this question in almost every single case is 0, okay? And so this is a very special log. You have to know this logarithm. If you ever see log base some number of 1, you know that the answer is 0, okay? All right, so now we're going to look at a couple more very simple logarithms. Okay, so here are 3 examples of simple logarithms that you should just be able to do right off the top of your head. Okay? And you're going to be asked 1 or 2 of these kinds on the quizzes and on the exams. Okay? So this is saying log base 2 of 32 is, so that means what exponent on 2, what exponent on 2 is equal to 32? Or 2 to what power equals 32? Well, we know that 2 to the 5th power equals 32. Therefore, the answer to this is just simply 5. The answer is not 2 to the 5th power. It's just whatever the exponent is. It's 5. Because 2 to the 5th power is equal to 32. Okay? All right, so now let's go to this one. 3, log base 3 of 27. 3 to some power equals 27. Well, I've already told you need to memorize that 3 to the 3rd power equals 27. So we know that the logarithm here, log base 3 of 27, is equal to 3. And then log base 7 of 49, 7 to some power equals 49. Well, we know that 7 to the 2nd power, or 7 squared, equals 49. And so the logarithm here is 2. 7 to the 2nd power is equal to 49. It really is that simple. Now let me give you just one more. What is log base 4 of 1? What's this one? Oh, well, we've already learned this one. 4 to the 0 power equals 1. Therefore, log base 4 of 1 is equal to 0. Okay? And now I just have 2 more very special logarithms to show you before the end of this video. Okay, now let's look at this very, useful. This is a very infamous, well-known, and you need to know it, a very interesting log. Not the 6, that's not what matters. It actually can be any number. The question is, what happens when we have the same number as the base of the logarithm and as the argument of the logarithm? What this is saying is that 6 to some power is equal to 6. It's saying that 6 to the power of something equals 6. Well, you should already know this one. We know that 6 to the 1st power is equal to 6. Also, 7 to the 1st power is equal to 7. 9 to the 1st power is equal to 9. And 12,400 to the 1st power is equal to 12,400. And so, what that means is the exponent on 6 that gives us 6 as an answer is 1. And this is important. This is very important when we get into when we start doing algebra with logarithms, is that any time you have a logarithm of a base of the argument that is identical to the base, the answer is 1. It's always equal to 1. So if we were to say, well, what is log base 2 of 2? That equals 1. What's log base 3 of 3? That also equals 1. So anytime you have log base a number of that same number, the answer is going to equal 1. Okay? So that's a very important logarithm or logarithmic fact to know. And then the last one is this. This one's just a very special logarithm. It is called the natural logarithm, and you just have to know it. Natural logarithm. Now, in order to explain the natural logarithm, I have to explain to you the number e. Now, you may say, Mr. Ryan, I know that e is a letter, not a number. Well, hang on a second here. Haven't you already learned a long time ago that pi is approximately equal to 3.141592, right? We know that this is an irrational number. We know that in math, when we put in the Greek letter pi, what we actually mean is approximately 3.14. That's what we mean. So when we do, the area of a circle, pi r squared, if we were told that r is equal to 5, then it would be pi times 5 squared. 5 squared is 25, so this would be 25 pi, which is approximately equal to 25 times 3.14, okay? So pi is a letter that is used to represent a number in math. Well, E is the exact same way. So the letter E is used to represent a mathematical constant that is equal to approximately, let's not put equals, let's put approximately equal to, just like pi, 2.71828. E is approximately equal to 2.71828, which means that 2, the number 2, is less than E, and E is less than 3. E is just simply a number that's between 2 and 3. Now you may say, well, wow, that's an interesting number. What does it mean? I'm not going to explain that to you right now, okay? Just know that it has something to do with continuous exponential growth. And because it has something to do with exponents, we see it frequently in logarithms, and it is the base of what we call the natural logarithm, okay? So the natural logarithm is basically this. If we were to say log base E of, let's say, 7, okay? Instead of saying log base E, and we know that E is equal to about 2.71828, okay? Instead of saying log base E of 7, we say ln, natural log. So we reverse the word natural and log. So logarithm natural of 7. Note we don't put a base here. That's because the base of E is implied. Natural log means log base E, okay? And so what we can do is this. What if I were to say, what is the natural log of 1? Well, the natural log of 1 means that E to some power is equal to 1. We know that E is a number, and any number to the 0 power is equal to 1, so we know that the natural log of 1 is equal to 0. We can also say this. Well, what is the natural log of E? E to some power equals E. Well, the answer is 1, okay? All right, now I'm just going to give you a couple other facts here with the natural logarithm. Just write these down. They'll make sense as we go. What if we said, what is the natural log of E to the 4th power? Well, what is E to the 4th power? Don't worry about it. It's just E to the 4th power. It's a number to the 4th power, okay? Just know that, okay? Well, this is basically saying that E to some power is equal to E to the 4th power. Well, this should look pretty obvious. E to what power equals E to the 4th power? Well, it's 4. And so the natural log of E to the 4th power is equal to 4. Similarly, if you were to see the natural log of E to the 53rd power, the answer would just simply be 53, okay? And so this is an important fact to understand. We'll use it a little bit later, okay? All right, so that is our introduction to the basic idea of logarithms and a few of what we call our special logarithms that we use frequently.